How's it going, guys? In this video we're going to be talking about Itertools, and I'm going to be showing you all the methods that come with this module so that the next time you have to use it you'll know exactly what each one of them does, so you won't have to read all of that documentation. Now first I'm just going to copy and paste in the first section from the documentation, which explains to us exactly what Itertools are. So Itertools are functions that create iterators for efficient looping. The module standardizes a core set of fast, memory-efficient tools that are useful by themselves or in combination. Together, they form an iterator algebra, making it possible to construct specialized tools succinctly and efficiently in pure Python. But to keep it short and simple, it just provides us a very quick and memory-efficient way of creating iterators, which are extremely memory-efficient. Now, the first function we're going to use is .count. And when you use .count, it makes an iterator that returns evenly spaced values starting from a starting point. So for example, if we have a counter and we say itertools.count, it's going to take a starting value such as 10. So this will start creating values from 10. And optionally, you can also insert a step. So you can say step 2 if you want to get only those even numbers back, or I mean, if you wanted to step 2 at a time. And something interesting about this is that you can also step with floats. But for now, we're just going to create an iterator using count starting from 10. And here we're going to type in for I in counter, and we're going to print I. And it's very important that we insert a break here. So if I is equal to 20, we're going to break out of this loop because this iterator is infinite, which means it's going to start from 10 and it's going to create numbers all the way until the end of existence, or whatever that limit is on your computer. So it's going to make the number incredibly large. So you need to add a breaking point. And if we run that, it will generate the numbers starting from 10 all the way to 20. And yeah, of course, you can add a step such as 2, and it's going to do 10, 12, 14, 16, 18, and 20. So that was the first method. Next, we're going to use something that's called a cycle. So to do this, we need to first create a list of elements, and I'm going to make an array of strings, so A, B, and C. And I'm very aware that instead of creating a list, you can just say ABC, but I'm going to stick to this convention of typing it in a list, because in reality, this can be a list of anything, and that's just to demonstrate that it's part of a list. But let's create this cycle. So I'm going to call it cycler is going to equal itertools.cycle, and we're going to insert the list. Now what a cycler does is essentially take that list and create an infinite loop with it, which means we can iterate over it as many times as we want. So here we can type in for I and letter in enumerate cycler, and what we're going to do is print I, the letter, and a separator, which is going to be this colon. And we need to set a breakpoint because this is infinite. And as with all generators, this will go on forever unless we have a specific breakpoint. So if I is equal to 20, we're going to break. Now, if we run this and we make this a bit bigger, you'll see that it's going to start looping from A, then B, then C, then it's going to start at A again. And this actually creates a copy. So once we exhaust the original list, it's going to start iterating through the copy. And it's going to do it for as many times as you want to do it. So that's how you can use cycle. Next, we have something called repeat. And this one's actually very straightforward. So we're just going to create a string, which is called string. And we're going to create a repeater, which is going to take itertools.repeat. And we just need to pass in what we want to repeat and the amount of times we want to repeat it, which in this case will just be 10. Now, if we try to print this, you'll see that we're not going to get those items 10 times because it will return to us this strange object. So with a lot of iterables, you would have to convert it to a list if you want to see it in a list format. So if you run this now, you'll get a list of 10 strings. That's a string. But you can still do things such as for I or for string in repeater. We're going to print the string and we'll get all the strings back up to 10 times because there are 10 strings in this repeater. So those were the 3 infinite iterators that come with Itertools. Now, I'm going to leave it to future me to explain the next section of Itertools, which are iterators that terminate on the shortest input sequence. So now future me is here to continue the video, and we're going to continue with the next method, which is accumulate. So to demonstrate this, we're going to create some numbers, and it's going to be a list of 1, 2, 3, 4, and 5. And we're going to say accumulation is going to equal itertools.accumulate, and we're going to pass in the numbers. Now let's print the list of these numbers, and we can make this bigger again. So if we run this, we're going to get 1, 2, 3, 4, 5, because that is the list of the list. But what we wanted to do is get the list of the accumulation. So if we run that, you'll see we'll get 1, 3, 6, 10, 15. Because it starts with 1 plus 2, which gives us 3, and then 3 plus 3, which gives us 6, and then 6 plus 4, which gives us 10, and 10 plus 5, which gives us 15. So it slowly accumulates these numbers. And if you want to get very funky, you can even import operator, or you can use any function you want, but I'm going to be using operator here. And as a second optional argument, we can pass in operator.multiply, and then you will get the accumulation of the multiplied numbers. Next, we have chaining. So to do this, we're going to create two different lists, A, which is going to be a list of 1, 2, 3, and B, which is going to be a list of A, B, and C. And we're going to create a variable called combined, which is going to equal itertools.chain. And inside here, we can pass in as many iterables as we want. And what it's going to do is chain them, which means we're going to treat these two iterables as a single chain or as a single sequence. So here we can now print the list of combined. And if we run that, we will get a single sequence back. And as I said, you can provide as many as you want. So we can even duplicate the same lists or provide it multiple times, and we'll get a single list back from it. Now we have a more interesting one, which has to do with compressing. So first we'll create a list that holds the values of A, B, C, and D. And we need to provide some selectors, which I will explain in a moment what they are, but they have to be true and false values, and they have to equal the amount of elements in the first list. So for example, we can add false, true, true, and false. Now we can create a variable called compressed, which is going to use itertools.compress. And what we need to pass in is the list plus the selectors. And if we print the list of the compressed, we're going to get B and C back. And to explain this very bluntly, we have the selectors here that choose which elements from the list will be returned. So 0 being false, it's going to say that, okay, A is not going to be returned because this is false. 1 is true, so it's going to select B, C is true, and D is false. So it's going to select the elements that you picked from that list. And it's not true that it has to match precisely, because if you do exclude one, it's just going to stop at C, since that's where this exhausts. So this can stop earlier depending on how many selectors you provide. Moving on, we have dropwhile. And we're going to create a list once again, which is 1, 2, 3, 4, 5, 6, 7. And we're going to type in remaining is going to equal itertools.dropwhile. And here we need to provide a lambda expression. And the lambda is going to take a number, which is going to check for the condition that n is less than 3. And we're going to pass in the list. Then we can print the list of this remaining. And if we run it, we'll get 3, 4, 5, 6, 7. And the reason being is that it's dropping the elements where this evaluates to true. And it's going to drop everything that is true. And as soon as this evaluates to false, it's going to print the rest of the list. It's going to stop elaborating it, and it's going to just print the rest of the list. So for example, if we have, let's say 1 and 2 after the 7, those will still be printed because this is only dropping the value while this is false until it evaluates to true, and then it's going to stop doing that. And if you have a billion numbers that are under the value of 3 or less than 3, this can have a large startup time because it's going to continue making that check until this becomes false, and then it will print the remaining of the variables. For the next example, I'm going to create a list of a range of 100, or maybe it's misleading to say this is a list because it is a range, but the concept is the same. We're going to pretend that's a list of 100 elements, and we're going to create a filtered list. So filtered is going to equal Itertools dot filterfalse. And here we're going to pass in a lambda, which takes n, and we're going to add the modulus of 10 to the list. Or not add the modulus of 10, but check that n modulus 10 is equal to 0. So the way this works is that when this evaluates to false, it's going to return it in the list. So everything that evaluates to false will be part of this filtered list, of this filtered object. Because once again, with every Itertools object, you do need to combine it or convert it to a list if you want to see the results in a list format. Otherwise, it's going to be treated as a generator. So here we can type in filtered, and when we run that, we're going to get 0, 10, 20, 30, 40, all the way to 90, because 10 modulus 10 elaborates to or evaluates to 0, which is false. It's a false value. And so does 30 modulus 10. It still evaluates to 0. 1 being true, 0 being false. It's going to return all the false values. And you can also just insert none if you prefer. And that's just going to return the false values from this list. So if we have, let's say, 0, 1, false, true, and we run this, we're going to get 0 and false back. It returns the false values, and that's what filterfalse does. Now the next one I'm going to show you is called groupby, and that allows us to group consecutive keys into a new iterable. So for example, I'm not going to write this all out because this is really tedious, but the list is going to look like this. It's going to be a list of tuples, which has A and 1, A and 2, B and 3, B and 4. So as you can see, they all have something that is repeating. So what we can do is type in a new variable or create a new variable called grouped. And I might add a space here so it's easier to read. And we're going to use Itertools as always .groupby. And here we want to group by, or first we need to provide the list we want to group by. And I find this very annoying that this is the first time that you need to provide the list first and not the predicate. But that's how it is. And we need to provide how we want to group it by. So we're going to do something simple here. We want to group the elements by the key of each one of these tuples. So here we have k at the index of 0 because we want to group it by these letters. So we want all the B's to be together, we want all the A's to be together, and we want the C, of course, to be together. So now with that being done, we can say for key and values, because there can be multiple values, in grouped, we're going to print key, and we need to convert that list of values, or that iterator of values, to a list if you actually want to see the values. Otherwise, these values will be returned in an iterator object. And the separator is going to equal a colon and a space. Now, if we run this, we're going to get these grouped back. So you can see A is with A, B is with B, and C is with C. So that was the basic way to use this. But there's another example that I must show you. And to do this, I'm going to replace all of this with numbers because this might be easier to show you that it's grouping consecutive elements and not just the ones that look the same. So for this example, we're going to create a variable called example, super creative, and it's going to return to us a list of G, which is the groups for key and group in Itertools.groupby, and inside here we'll pass in the list. Now we will print this example, and what you'll see is that it's going to group them by whatever is consecutive, which means 2 is not exactly going to be grouped with 2 unless it's in an executive order. So 2 and 2 must be together for it to actually be considered a group. And that's actually all I wanted to mention with this quick example, is that they must be in a consecutive order for it actually to be grouped. For the next one, we're going to use something called islice. And this is a way of slicing lists into iterables, and it's very similar to just using the syntax that we have in native Python with the colon. But of course it returns an iterable. So here we're going to create a temporary list, or a list of letters. And we're going to create a variable called sliced, which will take Itertools.islice. And here we want to slice the list starting from 2 for the rest of the list. So we do need to define the end limit, and if you put none, it's going to be indefinite. So by providing that and printing the list of the sliced, we should get CDEF. So it's starting from 2. If we do not provide none, it's only going to go up until 2. And there's not much to say on this one. It was that simple. I mean, you can easily use the slicing syntax, but if you want to create an iterable, use the itertools.islice. Now we have another one that's quite funky, and this is called pairwise. So if we have a list, or we're not, this is going to be called a list, but it's just a string, so A, B, C, D, E. So it's a string of characters. And if we say paired is equal to itertools.pairwise, and we pass in that list and print the list of paired, you'll see that it's going to pair each one of them as far as it can go. So A, B, B, C, C, D, and D, E. Those are the pairs it created from this list. If you have 2 or less, or actually if you have less than 2, it's not going to print anything because it can't pair anything. So you need to have at least 2 elements in your array, and this string at least consists of 5 elements or 5 different characters, so it was able to pair them. And that's really all you can do with this. So it helps you pair elements, which means if you had a list of numbers, it says 1, 2, 3, it's going to give you a pair of each of those numbers. So 1 and 2 and 2 and 3. Moving on, we have star mapping. And to demonstrate this, I'm first going to create an example. So we're going to once again import operator, or actually from operator, we're going to import power. And here we're going to create a list of tuples once again. So we have 1, 2, or that's a bad example. I need this to be 2, 3, and I need this to be 2, 4, and 2, 5, because we want to get the power of 2 for each one of these. So next we can create something called starmapped, and that's going to equal itertools.starmap. And first we're going to pass in the function. So here we're going to pass in power followed by the list. And we can add a underscore here so we get rid of that green line. But what's happening here is that we're passing in the function, and this can also be a lambda if you want, but it's going to loop through the list and it's going to extract all the arguments. So 2 and 3, 2 and 4, 2 and 5, it's going to extract those and loop through this and return the result of these being placed inside power each time. So if we print, let's say, the list of star mapped, you'll see that we will get 8, 16, and 32. Now, if you have a function that does not support more than the amount of parameters that you're providing it, it's going to throw an error because, of course, power only takes 2 arguments. But to demonstrate this example a bit more clear, I did create a useless function, and this function is called example. It takes arguments and it creates a temporary list. And then for each argument in those arguments, it's going to append that argument to the list as a string with X to it. So it does some very minor processing. And I did not mean to remove my list. I need to get that back. So we're going to create a list right above X. And this list will contain 1, 2, 3, 4, 5, 6, 7, and so on. So you can see these are arguments of varying lengths. Now, instead of power, we can just pass in example, which takes as many arguments as we have. So this actually can be set to 4 if we want. And when we star map this, it's going to place all those arguments into example. And that's why they call it star map, because you have the star here, which takes apart the arguments. And when you run this, you'll see that we'll get a list of 1x, 2x, 3x, and 4x for the first element. Then we'll get 4x, 5x for the second, and 6x and 7x for the final one. So it effectively placed all those arguments into example. Next, we have the opposite of dropwhile, and they call this takewhile. And what it does is create an iterator that returns elements from the iterable as long as the predicate is true. So let's create another funky example of a list. So list is going to equal 1, 2, 3, 4, 5, 6, and 1. So here we're going to say taken is equal to itertools.takewhile, and we're going to create a lambda expression that says we should only take while a is less than 4. and we need to pass in the list. Then we can print the list of taken. And when we run this, we will only get 1, 2, 3 back, because as soon as this evaluates to false, it ignores the rest. It's only taking it while it's true. So as soon as it becomes false, once again, it's going to ignore the rest. And if this is false from the beginning, it's not going to take anything. So it only takes elements while it is true, and then it stops. For the next one, I'm going to change the list up a bit. So now we have 1, 2, 3 and ABC. And here we're just going to return independent iterators from a single iterable. And to do that, we're going to create something called a T. So here we'll type in itertools.t, and it's going to take the iterable and the amount of times we want to duplicate that. So if we type in 3, we can say for iterable in T and print the list of the iterable. And when we run that, we'll get 3 identical iterables, which are completely independent. And finally, the last one from this section is one of the most common ones, and this is called zip longest. So here we have 3 different lists that we want to combine or zip together. And Python does have one that is called zip, which is exactly the same, except the one from Itertools provides us with some extra functionality. So for example, here we can type in zipped is going to equal itertools.zip longest. And here you pass in as many lists as you want, or as many iterables as you want. So ABC, and you can also provide a fill value for the values that are just not there, because you can't really combine these all if there are some missing. So by default, it's not going to go any further than the first 2 if one of the lists has only 2 values. And to demonstrate that, we will first start with saying for A, B, and C in zipped, and there we're going to press print A, B, and C with a separator being a colon surrounded by spaces. So if we run that, or actually, I did not know this, but by default, it's going to pass in none for each one of the elements that you do not provide. So as you can see, for true and false, we only have 2. So in general, if you were to just use zip, it wouldn't go much further than that. So here's an example, we're using zip. You'll see that it will only go to 2 because this is the longest. But with zip longest, it's going to go as far as you want it to. So even if we only have 2 values in C, it's going to zip all of them until 5. But what I was trying to mention earlier is that you can provide a fill value. So this can also be a string or some other value. And instead of none, it will replace it with that string. So it's a very efficient way to zip lists or iterables. Now moving on to the third and final part of Itertools, we're talking about combinatoric iterators. And I had to read this. Let me just show you what it looks like. These are the terms they used in the Python documentation. I can barely read that. Combinatoric iterators. So these are the ones you probably see the most being used with Itertools, or the most popular ones that you see around YouTube or in tutorials. And you probably heard of permutations or combinations or products. And that's what this section is going to cover. So first we're going to be talking about how you can create a Cartesian product of input iterables. So to do this, we're going to create 2 lists or 2 iterables. One's going to be of 1, 2, 3, and the other one's going to be of ABC. Now let's create an output, which is going to take itertools.product, and we want to pass in A and B here. And what we're going to do is say for T in list of outputs, we're going to print T. And if we run this, we're going to get the Cartesian product of these 2 lists. So we're going to get 1A, 1B, 1C, 2A, 2B, 2C, and so on. And you can also provide a repeat value. So repeat, and we can say we want it to repeat 2 times. So it's going to duplicate these lists 2 times, and we're going to get these large tuples, such as 1A, 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 1B, 1A, 1C. So it effectively duplicated this and created a much bigger Cartesian product. Next, we have permutations, which allow us to get all the permutations from a selected iterator. So for example, we'll create something called permutations, and we're going to get Itertools.permutations. And inside here, we'll pass in the list. And all we need to do now is say for group in the list of permutations. And we're just going to unpack them. So we're going to say print unpack the group, and the separator is going to be a space. And if we run this, you'll see we're going to get all the permutations of A, B, and C. So ABC, ACB, BAC, BCA, CAB, and CBA. None of these are repeating in sequence, as you've noticed. So we effectively got all the permutations of A, B, and C. If we did not unpack this and we just excluded the separator, it would return to us a tuple of the permutations. So just to make it look cleaner, I decided to unpack them and add the separator, so you could see the permutations of these letters. And optionally, you can also provide how long you want the permutations to be. So if you want the permutations to be of a length of 2, you can insert 2 as a parameter or as an argument, and it will only provide you with permutations of a length of 2. Moving on, we have combinations, and here we'll create a tuple of 0, 1, 2, 3, and we'll get right into it by creating a variable called combinations, which will equal itertools.combinations. And here all we have to do is provide a list. Now when we print the list of combinations, or maybe it's better if we do the same thing I did last time, so for G in list of combinations, we're going to print G. We should get all the combinations of 0, 1, 2, and 3 back. And I was missing a positional argument, so I'm going to insert 2. And this is the length of subsequences that we want to get back from the input iterable. So if we run that, we'll get 0, 1, 0, 2, 0, 3, 1, 2, 1, 3, 2, and 3. So these are all the combinations you can have with these input variables. And if you add a 3, it's going to show you all of the other combinations. So these are all the combinations you can have with these values, which means if 3 was used with 2 and 1, that's all you can put inside, and it's never going to repeat a sequence in here. But what if you do want it to be able to repeat sequences? Well, Itertools has one method that is very similar to this one, and that is combinations with replacement. But now when we run this, you'll see that it's actually going to repeat the numbers, unlike with the previous combinations. So you might have something that says 1, 1, 1, but with the previous combinations, we would never get that because you cannot have the same element repeating. And by same element, I mean the same one at the index of 1. Because if we go back to combinations, for example, you can see we have 0, 1, 2, but if we provide another 1 here, it will place that 1 inside there, because there are other combinations that you can create with that 1. This one is completely independent to this one over here. And that's why you can get the same value repeating, but it's never going to be the exact same value because these two are considered independent. So if you actually want to get repeating values, you're going to have to type in combinations with replacement, because that will give you the repeated values as well when you are generating these combinations. And with that being said, we've concluded every single method that is included with Itertools. I know I didn't really explain where you can use these, but I did show you how they can be used. So possibly in a future video, I'll show you exactly where we can use some of these. But for now, it's just good to know that you understand how these work. So when you do need to use them, you know immediately what they do, or you can kind of remember what they do, because that will really contribute to you coding faster and more efficiently when you know that these methods actually do exist. But anyways, with that being said, do let me know in the comment section down below if you found this video interesting, or if there's something interesting that I missed. I would love to read about it. And with all that being said, as always, thanks for watching, and I'll see you in the next video.